Okay, let's start with a question. How many of us have used language model in the last week? Something like Claude, ChatGPT, or similar? Please raise your hand. Wow, it's amazing how fast NLP have become from an academic idea to something that all of us are using in our everyday life. Today, we're going to cover the fundamental of NLP. At the end of the answer of this lecture, you know all the basic concept, who's, and it will make it easier to start with the field. My name is Ortal Ashkenazi. I'm an NLP researcher with 4 years of experience, most recently from Gong, where I developed NLP model for conversation analysis. Prior to that, I finished my master's degree at the Technion, and I have a background as software engineer. On a personal note, I'm currently looking for a job in NLP. I live in Kfar Saba with my 2 sons, my partner, and my big loud dog, and I love hiking. What is a language model? You can think on a language model like a black box, where the input is text and the output is also text, but contextually relevant. For example, if I input a phrase, what is the answer to life, universe, and everything, the language model might output the famous 42, referencing the Hitchhiker's Guide to the Galaxy. In practical terms, language model generates text. They read all the input text and generate the output word after word. To think about that, you can visualize the predictive text on your keyboard in your phone. If you input a phrase, the next word, the language model suggests what might come next. For example, the next word is I will. Behind the scene, the language model uses complex algorithm to output those suggestions. And this ability to output the next word make it very valuable in a lot of life applications, like personal assistant and so on. Okay, now I'm going to cover 3 factors that contribute to the explosion of NLP. The first one is the transformer architecture. This architecture changed the way we process text, made it a lot faster, and gave it the ability to capture longer dependencies. Then we have the pre-trained models that have been trained on vast amount of data and can be fine-tuned for a specific task, allowing fast prototyping and better results. And then open source tools that make everything accessible to everyone and democratize NLP. Okay, the transformer architecture has made their debut in 2017 by a Google team. Prior to that, models like RNN process text word after word, very slowly, what made it hard to capture long dependencies and even harder with large dataset, like text dataset. The transformer solved that by parallel processing of the text. At the heart of the transformer mechanism lies the attention. Attention allows the model to focus and prioritize on a specific part of the text. For example, if you have the sentence, she's eating a green apple, between the word eating and apple have high attention, and between the word eating and green have low attention. This ability allows the model to focus on subtle nuances and long dependencies. The most intuitive way I know how to explain attention is through reading comprehension we all learn in school. We were taught first to read the question and then to go to the text and find what matters, find answers. Attention does exactly the same thing. It doesn't waste any time reading word after word. It just focused on the most relevant part in respect to the word that's currently being processed. Okay. Transformer did not stop only on the architecture level. It also led to pre-trained model that used those architecture. Before that, if you like to perform a specific task like determine what is the emotional tone of a review, you would use a sentiment analysis that determine if a review is positive, negative, or neutral. If you like to translate sentences between English to Chinese, you would use a translation mechanism. And if you like to extract relevant data from text, you would use a question-answer model. Each one of those models has its own architecture, and they required a lot of data. And then came the pre-trained models, like BERT or GPT, and changed everything. You had a pre-trained model that has been trained on a lot of data and new general language skills, and then you fine-tune it for each task. Okay, what is the magic of pre-trained models? They don't need neatly labeled data. They can use a lot of unlabeled data. What is unlabeled data? Can you give me an example? Talk. What text? Book. What else? Wikipedia. Yes, what else? I didn't hear it. Louder. Maps. Maps, yes, it's unlabeled data. Okay, so if you think about text and unlabeled data, you have all of the internet, every book ever written, YouTube. So, mask language model use that. Their plan was taking a sentence and mask part of his word. The mask word could be in the beginning, in the end, and the model should suggest what comes in this mask part. For example, this is a grade, and the model predicts film with 70%, movie 6%, and idea 5%. So, in a nutshell, mask language model taught themselves language by filling up the blanks, filling up the mask words. Okay, so we have a pre-trained model that have been trained with mask language model on a lot of unlabeled data, text from the internet, all the books and everything, and after this phase, in your general language skills. Then we select a specific task, for example, translation. We crafted a data set of a couple of hundred sentences, English, Chinese, and fine-tune it. And finally, we have a model that is an expert and in this field and know how to translate Chinese to English, and even does better than previous architecture. Let's take a specific example, because we like numbers. There is the Stanford QA dataset. This is a benchmark in the QA task. When BERT came in, one of the pre-trained models, it just beat the field with this paradigm of pre-trained fine-tuning. In the squad 1.1, improving 1.5 points, and squad 1.2 in 5.1 points. It's crazy because the QA dataset, there are academic groups and people that work on it for years, and then BERT came and all of their work have been thrown to the garbage, more or less. Okay, this paradigm of pre-training and fine-tuning called transfer learning, because we transfer the model of the knowledge that the pre-trained model have learned from unlabeled data to a specific task and get better results. So the advantage of it is faster training time. In addition, we need less resources because the model already knows language skills, and the best is that we improve the performance in some of the tasks. Okay, now we move to the last piece of the puzzle, open source models. Open source models allowed researcher and developer to just download state-of-the-art models and fine-tune them to their own task. And so in days or even hours, they had the pre-trained model for their own task sitting on their desk. This democratized NLP and made prototyping a lot faster because they don't have to start from scratch each time. Okay, so we talked about the first NLP explosion, about the transformer architecture that changed the way we process text, about pre-trained model that learn from vast amount of unlabeled data and can be fine-tuned for a specific task using transfer learning, and about open source tools that made it accessible to everyone. And then came GPT-3. In basic, it's a refined transformer architecture, but what really set it apart is its size. It had 175 billion parameter. It's 1,000 times more than BERT, an earlier landmark in the field that we discussed in previous slides. All of this required a massive financial investment of $4.6 million. But the really big landmark was the fact that it showed that with large enough model and good enough training data, missions that in the past were unthinkable for a machine can be done with no code, with no fine-tuning. Missions like creative writing or coding can be done only with text, only with example, no code, no backpropagate. Everyone can create model, not just NLP researcher. In addition, GPT-3 inserted a new paradigm, how can we train model? No more only pre-train and fine-tuning. 3 new concepts were inserted. The first one is 0 shot, 1 shot, and few shots. 0 shot is just asking the model to perform a task from instruction. For example, if I ask the model, please translate English to French fromage, the model can output correctly. If I want to translate cheese from English to French, the model will output correctly fromage. All of that without any example. 1 shot is giving the model 1 shot to understand the pattern, and few shot, it's giving it few shots between 4 and 64 usually, and so it can understand better the pattern and nuance and the way you want it to respond to something. But still, all of this was without code, only with text. Think about the old transfer learning paradigm that we learned a few slides ago. If we want to create a model that translates English to French, we needed to create a data set of a couple of 100 or 1,000 examples, fine-tune it on this task, wait a lot of time, and then we had an expert. And now, all of this is accessible. Fast prototyping. I want to tell you a story. My first model as a data science was to create a model that determined if you need to reply an email. I worked on it for 4 months. I created a data set of 1,000 examples and fine-tuned the model. It worked perfectly, but 4 months, it's a lot of time. Fast forward to today. If we got this task today, probably what I would do is take a few emails, go to GPT, created a good prompt, fine-tune it, and then after days, I'm going to have a working model that I can show to my customer and know if they really need it. Do they need a model that reply email or not? Are those emails that I selected are a good choice or not? A lot of questions that you can answer only when the models meet people and people really try it. So fast prototyping, I think it's one of the biggest advantages of GPTs. Okay, the next landmark was ChatGPT. What is the difference between GPT-3 and ChatGPT? Reinforcement learning from human feedback. GPT-3 was great, but by inserting the 0, 1, and few shot and changing the way we train model. But still, it was limited to static data. GPT-3 tried to learn what user really wants. How do we like our coffee? How do we want a reply? Okay, let's see an example. Imagine you have to draft an email that respectively decline a job offer. Please read both of the example and think what do you prefer? What is more aligned with your preference? Take a minute and we'll vote. Okay, who prefer response A? Who prefer response B? Okay, so as you see, most people preferred response B, and actually the second response was crafted by ChatGPT. This is really aligned better with what you want, not only with static data, not only with filling up sentences, but it's really tailored to our own need. Now that we covered reinforcement learning, let's talk about trends that are currently shaping AI future. Okay. One of the fundamental limitations of language model is they are limited to static data. If they are trained last year, they won't know about new things, new ideas, new product. They are stuck in time. So if you ask them, what is the weather today? They won't know how to answer you. They might hallucinate, or better, they say, I don't know. So what is the solution? We can search online to see what is the weather today, concatenate the first two results, and then we'll get a model that is up to date and know how to answer what is the weather today. This approach, called Retrieval Augmented Search, or RAG, it means that we can inject the model new knowledge, or a knowledge that is specific to your business. If you're an HR company, you can insert your best HR way. If you're a commercial company that try to sell dogs, you can insert data about dogs. This is a way to refresh the model memory. RAG is great by pulling new data to the model, injecting it to the model, but still, it's only text. It's only passive AI. Agents are the next generation. Sometimes we want models that can be act on our behalf in the world. So that is exactly what agents do. It takes a task, break it down into steps, and actively perform each task with tools that he possessed. Let's take an example. I want to send my mom an email with some suggestion for plans for Sukkot for her grandson. So the model will first search on the web for local event on Sukkot nearby. Then it can draft an email. Afterward, it can approve it by me to see that it actually aligned with what I want. And then directly send it to my mom. It's amazing. No more passive AI, but AI that actually works for us. The next trend is multilingual. I just returned from 3 weeks at Poland. It was great, but what amazed me the most is how much language model bridged the gap between cultures. I booked all my hotels through Booking, and to my surprise, most of the hotels did not speak a word in English. I wrote to them in English, they replied in Polish. And to my better surprise, it worked perfectly and smoothly, without any problem. A few years ago, it was unheard of. Do you remember when ChatGPT Desk came out and you tried to communicate with it in Hebrew? It was awful. Useless. And now, sometimes I want to write a work email, I just draft it in Hebrew and say, drafted as a work email in English, and the first result is, wow. I almost feel like I live in the futuristic vision of the Hitchhiker Guide to the Galaxy, where translation happened smoothly and instantly, without any necessary need to insert a fish into my ear. Using those digital bubblefish, like ChatGPT, we get instant translation without any effort on our part. And we bridge the gap between culture, while each one of us can save its own culture, and all of us can understand each other. Okay, the last trend is multimodality. In the beginning, language model only work with text. You can do a conversation, ask question, but only with text. Then came images, and when I read an article, I can upload a figure and discuss with a language model about it. My niece broke her hand, I could upload the X-ray and ask it, is it really broken? And now we got to a new field of text-to-text. That means that I don't need to type anything. I can just talk, and the language model replied. That means that if I'm crying, it can understand me. If I'm laughing, it can understand me. If I'm nervous, it can say, oh, you're going to be great at your lecture, don't worry. And it's amazing. Okay, let's summarize all of this journey. We started with what is a language model, a black box where you input text and the output is also text. Then we got to the first NLP explosion. We talk about the transformer architecture that changed the way we process text. We talk about pre-trained model that insert a new paradigm of pre-trained fine-tuning that called transfer learning. And about open source tools that made everything accessible to everyone. Then we got to ChatGPT and GPT-3, that what really set them apart was their size and their ability to create model only with text and no backpropagate, no coding. And we finished with new AI trend, multilingual, multimodality, and agents. Thank you for being with me on this journey. Please stay in touch.